This is our first lesson of Unit 4 in the Advanced Functions course. This unit is on trigonometry, and we start off with this first lesson on radian measure. So you may have measured angles previously using degrees. We're going to introduce you to a new type of measurement for angles, and it is called radians. And unlike degrees, radians are more of a natural measurement. They don't have units as degrees do. And we will get into that, what a radian is and how it's developed. But first, we need to talk about radian measure and how it's defined using the length of an arc of a circle. So, if you imagine a circle and you imagine an arc on that circle, and an arc length is really the distance between 2 points on a section of the circle. And if we divide that arc length by the radius of the circle, we get an angle measurement. And that angle measurement is an angle measurement in radians. So that's how we define radians. Or rather, that's how we define an angle in terms of radians. It's the arc length that's formed by the angle divided by the radius of the circle. So you can see the image here is sort of drawing a circle at the bottom of the screen with that red line. That red line is the radius. And then we're going to form an arc that has the same length of the radius on the circle. So if we do that, then the angle is equal to the arc length, which is the radius, divided by the radius. So we'd have an arc length of 1. If we have an arc length that's exactly half a circle, that would be a degree measure of pi. And a full circle would be 2 pi radians. That's how our angle measurements are defined. So 1 radian itself isn't really that valuable of a measure. It's when the arc length is equal to the radius length. But if we have that situation and we repeat that process until we have a full semicircle, we find that the degree measure in radians for half a circle is pi radians. And then, of course, for a full circle, we would have 2 pi radians. So using this idea of a full unit circle that has a radian measure of 2 pi, and we know that in degrees, a full circle has a degree measure of 360 degrees, we can create some properties to convert between radians and degrees and vice versa. So using this idea that a full circle has an angle measure of 2 pi radians, or 360 degrees, we also know that a half circle has a degree measurement of pi radians, or 180 degrees. We can create some simple formulas to change between angles in degrees to angles in radians, or vice versa. So let's say if we had an angle in degrees and we wanted to change it to radians. To find that theta r, it would be the theta d multiplied by pi and divided by 180 degrees. Let's also create the alternate formula. If we wanted to go from radians to degrees, that would be our theta d, our angle in degrees, is equal to our theta r times 180 degrees divided by pi. So that's our simple formula to change. So let's try to apply this formula to radians, these formulas, and radians to solve these two example questions. So first we're asked to change every degree measure to radians, and then we're asked to convert the radian measures to degrees. So let's start. For example 1, let's do A. We are changing 90 degrees into radians. So our angle in radians is equal to our angle in degrees times pi divided by 180 degrees. This becomes, our angle in degrees is 90 times pi divided by 180 degrees. So our degree symbol is in the numerator and denominator, so the degree units disappear, and we're left with pi over 2. So that's our first one. Let's continue with part B here. We have 180 degrees. So 180 degrees times pi divided by 180 degrees. So this angle measurement is just pi. For C, we have 45 degrees times pi over 180 degrees. 45 divided by 180 is going to be equivalent to having a 4 in the denominator. And of course the degree units are gone. So our angle in radians is 4 pi radians. And then lastly for D, we have 225 degrees times pi over 180 degrees. And in this case, we are going to have this in terms of pi, but 225 divided by 180. If we put that in our calculator, 225 divided by 180 is 1.25, or it's 5 over 4. So that would be our angle measure in radians. So to convert from radians to degrees, these are the example 2 questions. It's a very similar formula and similar process. We substitute in our theta r here, and we multiply it this time by 180 degrees over pi. So our degree measurement, when we have 2 pi, the pi up here and the pi down here divide, and we're left with just 2 times 180, and you can notice that now we have a symbol of degrees, so we have 360 degrees. For B, our angle is negative pi over 4. We're multiplying again by 180 degrees over pi. So this becomes, actually it's negative 45 degrees. The next one we have 4. Actually, theta of D is 4 pi over 3 times 180 degrees over pi. So again, you could use your calculator for these. If we were to do this one, it would be, we can tell that the pi's are going to divide out. So this would be 4 divided by 3 multiplied by 180. And we're left with 240 degrees. And the last one, we have pi over 8 times 180 degrees over pi. This is going to simplify to, the pi's disappear, we'll be at 22.5 degrees. So that is it for this first lesson in this fourth unit. Your homework is listed here. And again, if you have any trouble, you can always email me.